getting back into the slides.
So you were going over, yeah, that
Yeah, yeah. You were talking about the ONU OMCI response and request.
Oh my God, I've been talking for quite a bit. So
I was actually gonna have a comment. So go ahead.
So when you adapt it like here, basically instead of me showing this part, let me show the actual code so that it's maybe it would be easier to see. Let me see the Pro Tools. This may be a little bit too. Is this too small?
That's
good. That's good for me.
Good? Okay, so what we have now, we have an adapter service. This is what we had before, which we call the iAdapter interface. So now it's all gRPC. So I call it an adapter service. So all the adapters have to implement that interface, that service. And also what I have this ONU inter-adapter service, and this is implemented by a child adapter. And here what you have, before there was this single message like send into adapter message. Now what we have 4 messages here, well 5. We have the ONU indication, the OMCI response, download tech profile, gem port, and tconf. And the OLT adapter needs to implement this inter-adapter service. And the only RPC I've seen is the proxying of an OMCI request. And I don't know if I had the chance to say that it was they are not, but pretty much the OMCI response and the OMCI request, we could potentially have only one message here. Basically, in the ONU adapter, it makes life hard if I just put one message, one like proxy OMCI, and without a response there, because it's just the structure of the Open ONU at this time. It just makes it harder to send an OMCI message and get the response right away. It has different threads, routines that are in different places expecting messages differently. So that's why I left it as 2 messages. Chip, you mentioned that you had a question.
Oh, well, just the OMCI requests can, and also packet in, packet out, also run without having to have a response. So I don't know if that matters or that provides any additional speed.
It doesn't matter, because like here, like this is the structure of the service. So it's it will just return an empty. It's just saying that the other side receive it.
Okay.
And this is like an adapter, like an OLT adapter will need to implement this service, the inter-adapter service, but also it needs to implement the adapter service. So there's 2 services that needs to be implemented. And the ONU adapter will need to implement the adapter service plus the ONU inter-adapter service. Okay, so that explains that one. So in terms of the endpoint logic, so the endpoint, before everything was done in the Voltha libgo, in the sense of when a component starts, it will go in the KV store, it will load all the adapters that are present, and it will build its own hash map for that using a common hashing mechanism, and then from there that will allow it to figure out to which adapter to send a specific device request. So that was all good, but that works well for Go adapters. It doesn't work well for Python adapters. So that was the problem. In order to support different kind of adapters, then in a way, everything had to be in Go. In this new mechanism, what I did, I moved that logic actually inside the core. Instead of being in the library, I make the core decide where to send in any message. Basically, what it does is it create an endpoint field. It adds an endpoint field to the device proto and also to the device proxy address proto. In the device proto, it's like which endpoint means an adapter endpoint that is responsible for that device. So the core figure it out. It's build a hash map and everything, and figure out and fix that for that device. And also it tells the device, if the device is a child device, it fixes the parent adapter for it as well in the proxy address, such that when a request goes to a child device or an OLT adapter or an ONU adapter, they will use that endpoint that already exists in the device or the proxy address to direct the request. So they don't have to build any hash map. They don't have to do any of those things. So that's one big change. And what it means is like we can have an adapter that stays in Python, and just as long as it can handle gRPC, and it will just look at the endpoints that are already defined in device and proxy address to direct the request. And also for that, there's some proto changes I did, and a lot of them have to do to remove some confusion, because there has been, like, we have been using adapter type, device type a lot of time, and at times they mean the same thing. So this is what I changed. I renamed the adapter field in the device proto to be adapter endpoint, because actually it is an adapter endpoint. And also I add the adapter endpoint field to the proxy. I rename adapter field in the device type to an adapter type, because that was causing a lot of confusion. And also I remove a few public imports and move around some proto definition. And those are required, because otherwise there would be a lot of circular dependencies in the protos. And those, whether we go with gRPC or not, those changes needs to be done. Otherwise, like, we'll get into trouble later on. So the next one. So Voltha lib Go. Here I borrowed some of the code that is in OF agent Go. I adapted it. It has a nice gRPC wrapper client in the OF agent, and I just take it and change it a little bit, add a little bit more functionalities to it. And this is the wrapper that all the components are going to use. And basically what it has automatic reconnect. If the remote endpoint goes down, it will just automatically write. It has some backup retries automatically built in. And it reconnect on specific gRPC errors. Like it uses a gRPC interceptor for that. It has keep alive. It keeps allow that connection. And also it provides a component, a restart callback. So when you start this client, you can also provide it with a callback to say, if the other end has restarted, let me know. And I use that in the core, for example, like to trigger device reconciliation. So if a specific adapter has gone down, when it comes back up, my callbacks get invoked. I say, oh, that adapter went down. Okay, let me do device reconciliation for that. And this, by having this gRPC wrapper in the client in the library, it just makes the code much simpler for the core and the adapters. And you will see that. And there's a bunch of cleanups too in the library, like adapter interface, com proxy, adapter proxy, those are all gone. The Kafka intercontainer related code, all gone. And also I updated the Sorama client to use only proto messages instead of Kafka intercontainer message. And what else here? There's obviously some changes in the hand charts. I added services for Open ONU and Open OLT. Each replica of the component has a unique endpoint. And in the demo, as you can see, it was a one-to-one relationship between the service and the component instance. We may want to change that later on, but I've looked at the code, especially the Open ONU and the current Helm charts. It appears that we're expecting to have only one instance of each. So that's why I didn't play too much with how we're going to configure the services there. I also tried to have a headless service there, but for some reason the gRPC was not having a hard time to connect to the service. That's why I didn't spend much time on that. Maybe that's a way to do that, but for what I tried, it was not working. Again, like if we want to support multiple replicas, so we need to do some work around how we configure those services. And also there has been some cleanup, like some topic reference has been cleaned up for intercontinental communication. And also I clean up some input parameter changes, and mostly are reflected. Those are in the core, because in the core we're using certain timeout, that long timeout and all those things. I clean that up, so that doesn't need to be part of gRPC, but it's just like as I was cleaning up, it was just convenient to do that. So the next thing, okay, so
do we actually need services at all? Pods should be able to access other pods. They have a name. They're in the namespace, in the DNS namespace.
So we could. I did try that option because I use the service. I say, oh, it's working. Okay, I'll stick to that, and later on we'll figure out what's the best. So, but like you said, yeah, they can. We may not even need a service if we're going to go like. Well, even if we have multiple replicas, we can just connect to each other directly. And
only if we want some sort of load balancing or something of HA with the services, we use, I think we use that.
Yeah, and in our case, we won't even need. We can't even do this load balancing because we want, like, in a way, the adapters or state. They are not stateless; they are stateful. So each one of them, they control like a certain adapter instance control a specific device. So device don't move, so we can't really have load balancing in that case.
Yeah, that's the same thing we're doing between OF agent and ONOS, because we want OF agent to connect to all of the ONOS instances. So we're passing it all the 3 pod names.
Yeah. So that's like I said, this is an area that we need to look at a bit further. So let me go through a little bit of. I just want to quickly go some on the patterns that we have seen. Let me maybe I'll just show a little bit. Well, just quickly. Before, when we're making a request, when an adapter makes a request to the core, we have a lot of messages like that in the core. Like, for example, a child device detected. We're getting the message in. We have to verify that we have the right length, and that was really arbitrary. If anybody put a wrong number there, then we're screwed. And then there was a lot of those different kind of messages that we're doing here and marshal the data, and you can see there's a lot of marshalling, and eventually at the end we call the child device detector method. So there was a lot of that, but now if you look at the core code, this is a method that used to be called, but now with gRPC you call it directly. This is the way it works. You call it, and it returns a device or an error. So that's make the code much simpler, and for debugging also it's way easier. And another thing that I wanted to show, like, and the same applies, like when the code was sending to an adapter, for example, send and download image, it has to figure out like the topic. It has to figure out like it has to put messages in those kind of structures, and then send it to the proxy, and the proxy will take that and massage it, marshal it, and send it on the other side. So there was a lot of complexity that we no longer need to have. And if I take, let me take maybe the open, just to show some of the code changes here. I'm just going to get rid of that. So first, what I'm going to show. Let's take that out. If you look at, maybe I can do it diff here. Oh, it's not showing the. Refuse to show the other screen. Let me see if I can show this way. Okay, so here that may be too small, but I'm just going to increase the font size here. You can see like in the code before we have those iAdapter, stuff like that, intercontainer, and here what we have the core client. This that's a gRPC thing. We have the gRPC server that is hosted, and this is the OpenONU code. And before we have those receiver channels, and this was to get messages from the Kafka. We no longer need that. And let me go for some of those things, like all the code about setting up intercontainer proxy, that's gone. Core proxy gone. Event proxy is still there. It shows as deleted, but actually it's here. And also what we do now is for the core, we create this client. This is what I call this wrapper. We create that. We provide the core endpoint. We provide a restart. If the other end got restarted, this is the restart callback, and we'll provide a bunch of parameters to it. And also, this is what we do is we create a gRPC service. Like that's the server that we have, this gRPC server. We add the adapter service. Like I said, there's two services that needs to have. It's the adapter service, and for an ONU adapter, it needs to have the ONU into adapter service. So it add the adapter service, is add the ONU service, then it's done the gRPC service, and that's it. That's all it needs to do. And let me go to here. I'm going to show you some of the code differences. Okay, so here, let me go to some. You see those process into adapter, OMCI, receive message, all these are gone. Like all those marshalling of data, that's gone. Want to show. Like we had before, what we had in the OpenONU, we had this process into adapter message. It was like a generic method and was looking at each message type to figure out if this, for example, OMCI received message, is it an adapter, a tech profile download, is it delete? So it was looking at all those different ones in order to dispatch. And then in each one of those methods, there was some further marshalling of that message to figure out what to do. But that's gone. What those get replaced? They are replaced by, let me see. It's not being highlighted here, but for example, well, it's not highlighting here, but I'm just going to switch here. I'm just going to show another thing. But basically, it's like it's those 5 other messages that needed to be implemented. It just in that diff, it was not showing the difference, but it's there. And the other thing that I wanted to show here, let me see if I can do a diff here. What I want to show is how the call is, come on, how we make the call to, this is way too small, come on. Okay, let's see, make it call to the, come on. It's trying to show how we make the call to the, for some reason it's not highlighting much. Let me see here if I can find it. Okay, so here is an example. If we want to call the call, make it, for example, here we want to get the device. Now what we need to do, we need to get the, because we defined this call client before, we invoke this method, get call client. So basically here, what happened, every time we want to talk to the call or to the other side, we need to invoke, like for the call, we have to say get call client. And what it does, it returns us the latest call client in the sense of you may have a connection that has been broken up to the other side and rebuilt. So you really have a new connection. So this method will always give you either nil, means the connection, there's no connection to the other end, or it will give you a connection that actually works because it's verified that connection. And once you get that, this is what you do. We call the get device directly. So there's no, the other, those called inter container, call proxy, that's no longer do that. And if you call to the parent adapter, like in here, what I'm calling this, I call get parent client service here. But this one itself, basically like it's just a method that, it's too small to see. But basically I'm giving it the parent endpoint. I'm telling it like, go to this parent endpoint and get the client for that. And then I make this, for example, here I'm saying, and I'm sending an OMCI request for that. So this is the code changes. Like you can see, it's not big changes in the adapters. It's just the way we're handling it. It's similar as before, except it's much clearer. And it's most of this client handling and everything is done in the library. So I I realize we're already 12. Been talking too much, so I'm just going to skip this summary here. Well, as a summary, it's like all the code that you have seen. This is rebase with Voltha release 2.7. So it's really the latest code that has gRPC in it. It passed all the unit tests, so I've updated a lot all the unit tests to make it work. Functional tests on AT&T, DT, and TT in the single node cluster, that works. And like I said, it works with OF agent and Voltha as is. And in my test, it has shown overall performance improvement compared to Kafka. But to get the actual measurement, then we need to do proper scale testing, which I've not done. And in terms of remaining work, well, it's test. We have to test the entire thing and any code reviews. And what next? And I think that would be maybe another TST, but bottom line is, do we want to get it in the release 2.8, or are we going to wait for a LTS release? The pros for 2.8 is like the code is pretty much ready for review and further testing, and means a massive and needed migration would be done. And going forward, the code will be simpler, cleaner, and definitely easier to debug, and would benefit and overall improve performance. And obviously the cons, if we go to 2.8, it will take some work to do the testing and resolve any issues. And what it means is like we can't really submit some major code into the code base during that time. We can submit like patches, stuff like that, because it's easier to rebase. If we submit bigger code changes, it just makes life a little bit harder to do the rebasing, but it's still feasible. And if we wait for an LTS release, the pros is, well, nobody's expecting it, and the cons would be, are we going to be limited by backward compatibility later on after we do an LTS release? I don't know. It's something I have to figure out. And also my real fear is that if we keep kicking the can down the road, then what's the chance that we'll ever take the time and says, okay, let's do this migration? I don't know. So that's pretty much it. I know I'm past the time, but if there's any question, I'm ready to take them. And I hope I've been still connected at this time.
I think we have to go back to slide 9 again. No.
Yeah.
I don't have a question, but I'm in favor of this, particularly if we start looking at security and other things too. That's an add-on to this, right? You just use the standard capabilities of gRPC versus trying to have to kind of hack it. Even some of the Jaeger stuff that we kind of had to hack in around Kafka.
Yeah.
So I think it's better to get this in now. I think the rebase is going to be a pain. The code, the fact that you're ripping out code, is a big plus in my mind.
Yeah, it's definitely, as I was doing it, it was so much simpler. I find, especially the one component I believe would benefit the most out of it is the Open ONU adapter. It would just make things much simpler for them.
Yeah. Yeah.
Yeah, I think the two main reasons to get it in sooner than later are that keeping these changes up to date with the latest code will be a huge pain.
Yep.
And they simplify the code base a lot. And also if we do an LTS and we switch the communication method right after, then there's not much point in having an LTS that has a completely different communication mechanism.
Yeah. Exactly, yeah.
Yeah, it could become a nightmare to backport fixes stuff in the LTS. So, I mean, I think that's a bigger conversation that the TST will need to have.
Ken, one Question. So as part of, in the previous, in the current interface, right, on the iAdapter interface, so the entire device structure is passed in most of the cases, right, between the core and the adapter. So
yeah, that's correct.
a suggestion of simplifying that as well, because not all the data is needed for most of the APIs.
Yeah, a lot of this has been simplified indirectly already, in the sense of like when we pass in the device object today, the device object is when you do a get device, actually what you get, you don't get the flows, you don't get the ports. You get just the core of the device, like whatever is at a high level in the structure field, because all those other thing has been moved outside of it. So already it's a smaller size of the device that get passed by. And if there's further improvement that we can do there, definitely we can do that. That's not a problem.
Yeah, basically to break the binding between the interface and the way the data is stored in the backend, right, or in the database. I think that is something we could also think of doing as part of this exercise.
It's if I think it needs to be done, but I don't know if it needs to be done as part of this exercise, because it's really two different things.
I would keep it as isolated changes. I do think we need to change the backend storage, but yeah, I don't. One thing, do one thing, test it, do the next, maybe.
Yeah.
Yeah, this change seems big enough by itself.
Yeah, it's a lot of changes, but it's those are simple changes in the core and the adapters. Because a lot of it is like you will see, like it's mostly like the method signature have changed, but the core of the method have not changed. It's the same.
And you should be able to support multiple replicas, or did you say that was going to be maybe some of the
no, it can support multiple replicas, because the way it is set up, it definitely can set up multiple replicas. The only reason I didn't set it up that way in the demo is because when I was looking at the OpenONU Go code, I was not even seeing the replicas in the Helm charts. So it was kind of like saying, oh, maybe we're expecting only one-to-one mapping. That's why I didn't spend a lot of time. But definitely it can do multiple replicas, because the core itself, I tested it with mock adapters, with a lot of adapters and a lot of devices, and it was supporting multiple OLTs and multiple ONU adapters. It was able to do that.
Okay. Yeah, if this is tremendous speed up, there might be some fixes. Go ahead. Sorry.
Oh, sorry, just to clarify on the OpenONU Go adapter, it should be in theory capable of supporting multiple replicas, because it's using the endpoint manager in the Voltha libgo library. Just has never been tested as we can reach the scale that we need with a single instance.
Yeah, like me, I was just looking at the Helm chart. I says, "Oh, this is what we have." So we'll just. But if we need to do that, that's it's there. The code is there. It's just a question of configuration.
So oh, go ahead.
Yeah, go ahead. Okay, go ahead, Matteo.
I had a question on device reconcile. If this changes anything, because the way it works now is that once we push messages on Kafka, regardless whether the adapter is there or not, it's gonna receive them sooner or later. While with gRPC, if the client is not there, the adapter is not there, some messages may get lost. Will this affect the device reconcile or not? Because the messages we send on Kafka are going to time out anyway in the sender, and so we basically don't care about those anymore.
Well, when it comes to reconcile or any other messages, like currently we send message over Kafka and we forget it, and we don't really know what's happening after that. Like the adapters maybe take them off, take them on, execute them, or maybe don't do anything with them. But today, when we send with gRPC, if we send a request down, if the adapter don't get it, we'll get a timeout right away. We know that the end didn't get it, or the adapter can provide us with an error. And then now we have to behave differently in whichever is sending that request. For example, if the core is sending a reconcile request to an adapter, and the adapter is not available at that time, now it's up to the core. The core will have to find some way of back-off mechanism to invoke that reconcile again. So it's up to the sender to make those decisions. And no longer, like, we can't just rely on Kafka to see if those messages have been processed, because we don't know how long that adapter was down, and maybe there's some other request that has come in that would have been different, and maybe not in the case of reconcile, but if we take a case of, I don't know, enable a device, or a reboot of a device, or disable of a device, are they really relevant after a certain amount of time if they have been sitting there on Kafka? So it's a different way of looking at things.
I was asking a similar question. So what if an adapter doesn't keep up the message send rate from another adapter? So do you know the internals of this gRPC server implementation? Will it create lots of threads if there are lots of messages and it cannot keep up the message rate? What will happen?
Do you mean if someone makes a lot of gRPC calls and each are invoked in a separate thread, how do you just stop, like, essentially a denial of service attack?
Yeah.
There are some parameters on gRPC that actually you can set on the server side, that you can set to handle a certain limit of messages. We have not used it, but it's possible to do that.
Additionally, if we wanted to, and this is more code, we could have it such that the gRPC handlers essentially in queue the workload within the process, right? So the handler essentially just puts it on a queue, and then you could actually control the number of threads within the process to ensure that you don't get thread overload, right? So there's various mechanisms that can be used around that. Or, as Ken said, you could just say, look, there's a parameter to gRPC which says this many calls, and after that you start getting blocking until the threads free up.
Is there any reason you were thinking about that? Do we have this situation today?
Between OLT adapter and ONU adapter, it might be, because we are sending OMCI messages, and it goes to the devices, and also it could be between maybe RW core and OLT adapter when the messages goes to the actual device. For example, flow insertions. So if we when an OLT is restarted, all of the flows are regenerated and all of the flows are pushed into the RW core and then OLT adapter and then later OLT device itself. So there will be multiple messages at the same time that need to be processed. So
I mean, I think it makes sense to protect it from message burst, and I think one thing we need to do is run a scale test on this, right, with 1,000 ONUs. And I suspect that test we're going to actually have to set the gRPC limits. Although 1,000 Go routines can be handled easily enough, but you're talking 1,000 times how many concurrent requests. I think that needs to be tested. But again, I think there's mechanisms to do that, to work around some of those issues, or at least control it from a gRPC thread explosion.
Yeah, definitely. Like it's because I've tested it locally. I've not tested it scale wise. So we'll see different. It may be a different story during scale. So it's definitely needs to be tested.
We should be setting those thread limits anyway on all our code, just in the interest of self-protection, regardless of Kafka or whatever, right? Any time you use gRPC, we should probably be practicing protection.
Yeah, I agree. Any other question?
Just one thing, if you can maybe share the PDF version of the presentation of the mailing on the mailing list in case someone else want to take a look offline and go through it again.
Yeah, sure, no problem. I'll do that. But I'll send it to you so you can add it maybe to the minutes.
Oh, yeah, sure. I can upload it to Google Drive and put a link in the notes.
Yeah.
Okay. We are 15 hours, so if there are no other questions, I think we can call the meeting done. And thanks, Ken. It was very interesting.
Okay, thanks. Okay, thanks everyone.
All right, thanks, Ken.
Okay.
Bye.
Thanks, Ken.
Okay, thanks,
Thank
bye.
you. Thank you,
you.
Ken. Bye-bye.
Bye.
Thank you. Bye.